So good morning, everyone. Let me take a minute to introduce you about this program. So RISE is Reboot, Invest, Scale, and Empower Yourself. And this is an initiative from Women Who Code Hyderabad chapter. And so this is basically to enable women on a career break to return to work. So all initiatives taken by Women Who Code is to inspire women to excel in technology careers so that they can see a world where diverse women are better represented as engineers and tech leaders. So everybody gets an equal opportunity to participate in this. Women Who Code, all the activities conducted by Women Who Code, irrespective of their demographic characteristics, political affiliation, or socioeconomic status or preferred programming language. And Women Who Code does not tolerate harassment of members in any form. So please adhere to the code of conduct, and you can read the complete code of conduct at womenwhocode.com/code of conduct. And I hope you all have already become a member of Women Who Code. So with that, we have, we'll get started with the session today. And we have a new trainer. His name is Kuldip Singh, and he has around 5 years of experience in this industry. He's been working with the MNCs, and I think he will be a good trainer for us today. So Kuldeep, over to you. I'll stop sharing the screen. So Kuldeep, you can get started with your session.
Hello, Nandini. Thank you. Hello. Good morning, everyone. So we'll start with the session. Give me a minute. Nandini, I'm starting to share my screen, so I'm reconnecting for permission issues. Okay.
Okay, are you not able to share your screen?
No. So Zoom is asking for permission to share, so it is saying that quit and reopen because I just given it the permission. So.
Okay, at your desktop. I mean, in your machine.
Yes.
Oh, okay. Kuldeep, we can't hear you if you're talking.
Okay. Able to hear me now?
Yes, we can.
Okay, so I started sharing my screen. Are you able to see it?
Yes, we can see using lambdas in Java.
Okay, thank you. Then we'll get started. Okay, so hello everyone. Once again, I'm Kuldeep, and we would be starting with the using Lambda expressions in Java code today. Okay, so the session title says that using functional interfaces, but all these are connected points only using lambdas, functional interface, and method references. So we'll go the other way around and then we'll connect all the dots together and we'll able to see how these works. Okay. So before we start here, we'll have just a quick discussion on what we should know before we start this course. So you need to have at least some basic knowledge about the Java programming language, and you need to have like some basic
Kuldeep,
knowledge. Yes.
sorry to interrupt. Can you talk a little louder because your voice is very low?
Okay. 1 second. Is it better? Hello. Is it better
Yeah,
now?
yeah, but still we like it's very low actually. Can you?
Very low. Okay. Let me connect my headphones. So we were discussing like the prerequisites of the course. So in this example, we are going to use the collection framework as well for the code snippets and examples. So you need a little understanding of that as well. And of course, since this is a Lambda expression course, you need to have at least Java version 8. Lambda expressions have been introduced in Java 8, so it is a Java 8 plus course, and they have not been backported to prior to Java version 7. Even if you have Java version 11 or past 11, that is fine also. Okay, so so this is how we are going to proceed today. So what's in it in the course for you? So well, we are going to cover several key points about how to write and efficiently use Lambda expressions in our code. So first we are going to see how to write Lambda expressions in a very simple way. And I'll give you a thumb of rule kind of a method that would help you, the beginners, on breaking down to converting a program functional write a functional style of code from the normal procedural kind of code approach, and then you learn on how to invoke the lambda expressions once you have written one, and how to use it to do some computation. That's the second point. And one of the tricky points in dealing with the lambda expression is how you can know that what lambda expressions you need to pass along to a given method. So we are going to cover that. And next we'll see how you can chain lambda expressions and how you can compose them into different types of lambda expressions to form the complicated and more refined lambda expressions in your code. And at last, we'll cover method references. So those would be the points today which we want to cover. And at the end of the session, you would have a very good understanding on how to use the lambda expressions efficiently in your production code. That's the hope. Okay. So, sorry. First, now that we have covered that up, let's jump into the technical aspects here. So at any point, if my audio breaks or you have any questions or you are not able to follow up, please stop me, let me know, and we can go it on again. Okay. So the first thing which we are going to see is the definition of the functional interface here. And that is absolutely mandatory when dealing with the lambda expressions. And we are going to see why. So once we have covered that up, we'll see how to write lambda expressions from the functional interface, and then we'll see a simple example of well-known interface from the JDK. So let us do that. Okay, so let us start by talking about the functional interface. Okay, so what is a functional interface and why it is so important in writing the Lambda expressions or functional style of code in post and from big Java 8? So the first thing you absolutely need to understand and remember is the following, that a Lambda expression is an implementation of functional interface. This is absolutely key point. And if there is one thing which we can remember throughout this course would be this definition, that Lambda expression is just an implementation of functional interface. So it means that despite what all have been read and said over the internet, the one thing which is not true is a Lambda expression is not another way of writing the instance of anonymous class. Okay. A Lambda expression is not another way of writing instance of anonymous class. Now, if you do not know what an anonymous class is, then that's fine and you are lucky, because nowadays you won't be seeing it much. But if you do, then you need to realize that an anonymous class may implement any kind of interface, not necessarily functional interface. And it can extend any kind of class as well, whether it is a concrete class or an abstract class. And this is not the case for Lambda expressions. A Lambda expression is an implementation of functional interface only. Okay, so it doesn't work same as anonymous classes at all. All right, so given that, what is a functional interface? So there are only two words here, so that's not very complicated. There is a functional, that's it, and there is an interface. Okay, so a functional interface is an interface, that's the first point. And the second point is, what does make an interface functional interface? So there is only one thing that does make it a functional interface, and it's the fact that a functional interface has only one abstract method. Okay, it means that the default methods, which are instance methods, and the static methods that you can define in an interface, do not count in this total. Okay, only the abstract methods do count. So I'm again telling, a functional interface would have only one abstract method. Static methods and default methods would not count. And now there is something a little odd, is that if you add abstract methods from object class, like you already know that every class or an interface has the parent class, which is object class. And object class also do have the abstract methods, right? Like there is an equals method, there is a toString method, and so on. So the abstract methods from the object class like toString, equals, hash code, those abstract methods also do not count in the total of number of the abstract methods which a functional interface have. So a functional interface may have one abstract method, as many default methods and static methods as you need, and it can also define the methods from the object class, especially the abstract method from the object class. Okay, they would not come into the count of number of abstract methods the functional interface needs to have. But now you may asking yourself that why would I put the methods from the object class in an interface, abstract methods from object class in an interface? Because an implementation of interface will be a class, and a class that extends the object would also be also the same class which would be implementing this interface. So this class is bound to have toString, equals, and hash code method anyway. So why would I bother adding them to interface? Well, in fact, if you check the JDK, you'll see that there are several methods of such kind. Like in the collection interface, there is a toString method. and they are sorry, especially the equals method. And the reason is that it's that those interfaces are changing the documentation of those methods. Like in case of the collection, right? The documentation and the semantic of the equals method has been changed and been written more specific as per the collection interface in the collection framework, right? So that's it. Mhm. So a functional interface is an interface which would be having one abstract method only. Sorry. So you are able to follow till here, right? Can some of you acknowledge? Just give me a minute, okay? हेलो सर, मैं बाद में कॉल करता हूँ, अभी मीटिंग में हूँ, राइट? सर आज तो नहीं हो पाएगा, आप घंटे भर में कॉल कीजिए, मैं मीटिंग के अंदर। ओके। हेलो। Sorry guys, I'm back. Are you able to hear me? Hello.
Kuldeep, yes, but still your voice is very low as and when you start, explaining, it becomes very low.
Okay. Then I guess I have to speak louder.
Yes, that is that is the thing.
Yes, yes. Okay. Where will be? So till function definition of functional interface, we are good, okay? Or you want me to cover quickly again, or we can proceed further?
Like not sure what was covered. I'm very sorry to say.
Okay. Okay. I'll go quickly again. So we were talking about the functional interfaces. Okay. So, and why these functional interfaces are needed and how they are necessary to implement the Lambda expressions. So we were discussing that a functional interface through the definition that a Lambda expression is just an implementation of the functional interface, and at a lot of places in internet and in the books as well, it is mentioned somehow that a lambda expression is another way of or another approach of implementing the anonymous classes, but that's not true. A lambda expression is just an implementation of functional interface, and lambda expressions and anonymous classes are not similar or same thing, because an anonymous class can implement a interface, a functional interface, and abstract class, and it can extend the concrete class as well. But a lambda expression can just implement the functional interface only. Similar to anonymous class, it cannot extend a class, either the concrete class or an abstract class. Okay, and neither can it implement the interfaces which are non-functional. Now, given that, then we wanted to discuss like, okay, and lambda expression is just an implementation of the functional interface. That's the definition. Now, what's the functional interface? So we were discussing that a functional interface, like from the words it says, functional and interface. So two words. So functional interface is interface first, and then we'd say what is a functional interface? So the word functional says, the definition of what it says is, a functional interface need to have only one abstract method. Okay, so any interface having only one abstract method can be said to be a functional interface. All right. Now, interface from apart from the abstract methods could have the static method as well, default methods as well, starting from Java 8 only. So those static method and default methods the would not be counted in the definition of the functional interface. Why? Because the definition of the functional interface is like that interface should have only one abstract method. So a functional interface would have one abstract method and could have multiple default or static methods. So that is fine by it. And one more trick is, or quick point to be noted is that because object is a superclass for every class or interface in Java, right? So object is a superclass for functional interface, any functional interface as well, right? And object class also have abstract methods, right? Like hash code, equals. These are the few of the abstract methods which are there in the object class. So if you now think through that scenario, you would see that, okay, if I create a functional interface, or if I see a functional interface which has only one abstract method, right? So then it would also have the abstract method from the object class as well, right? Like it would have abstract method from object class, which is equals, hash code. So would they also count, or would they not count as per the definition of the functional interface? So no, I'd like to say that only the abstract methods which are defined or declared in the functional interface, only those method count. The abstract methods which are coming from object class or the parent class or the parent interface would not count. Only the abstract method defined in the functional interface would count. So again, the definition of the functional interface is an interface having only one abstract method and as many default or static methods could be said to be a functional interface. All right. And one more thing to be discussed here to clarify is that someone may ask that, okay, the because let's say object class has equals method, right? Abstract equals method. So in what scenario uh, one would like to over, override that equals method in his functional interface, right? Because anyway, a functional interface is always going to be implemented by some class to create the object, right? And that class is anyway going to have the uh, method signatures of equals method from the object class also, right? So why we need, in what scenario we are going to do such thing, that the abstract methods of object class we are putting in the functional interface. So in the scenario would be like the abstract methods in the object class are defined in more generic way. They are having more general contract, okay? But we want to change the documentation or the contract for them to our specific needs. Like if you notice in the collection framework of JDK, the collection is an interface, right? From the collection framework, and the collection overrides the equals method from the object class to write more specific documentation from the collection perspective, not from the generic perspective, right? So in such cases, we may need to, or we may see such kind of the code implementation where the abstract methods from the object class are overridden into the functional interfaces. All right. Okay. I hope it is clear till this point, and we can move forward. Any questions so far? It is a more of a theoretical for a while, but we'll cover the code snippets and examples. So it would be a little interactive.
Yeah,
Any questions?
that is the point, Kuldeep. If it is a theoretical part, yeah, okay. It will be better if
Yeah,
it is a practical.
yeah, but little bit of definitions and concept if we can discuss, then it is helpful, right?
Okay, sure.
Okay, so now how we can implement the functional interfaces. So we will like to discuss that. So if you see the first uh, three lines of the code, so this is one of the functional interface. So all the functional interfaces in the almost all the functional interfaces which we see in the JDK are from java.util.function package, and this is one of that interface, supplier interface. So it has one method only, that is a get method, and it is a generic type interface, so it returns one return type of t. Okay, and now we want to implement this functional interface with the help of a Lambda expression. So we'd like to see how we can do that in a rule-based approach, so that we can do it quite easily. Okay, so the first thing we need to do to implement the Lambda expression looking at any functional interface is, you see, you just copy the formal parameter section, okay, of any functional interface method which you want to implement as a Lambda expression. So we copy the formal parameters as it is. So in our case, till now, there is a no formal parameter in this method. Okay, so we copy it as it is. Then we create a mega arrow. Okay, so a simple arrow. And after that, we write our body of the Lambda expression, which is any valid combination of any valid statements in the Java. All right. Another point to be remembered is, sometimes when we are new, we confuse the mega arrow with the fat arrow, which is not the case in Java. That is used in JavaScripts mostly. Okay. So now given that, uh, let's see some code examples. You are able to see my Eclipse screen, right? Not this. You are able to see my Eclipse screen?
Yes, Kuldeep.
Okay. So this was the supplier interface which we were discussing. So if we go back, okay. So this is the documentation of the supplier interface, right? So supplier interface with a single method get, which has a no formal parameters and one return type, which is a generic type T. So like we discussed, how we are going to implement it, right? So like I mentioned, just copy the formal parameter section as it is. Okay, so here I copy the formal parameter section, and then I write a mega arrow, and then I write any valid Java statement. So now because the get method has to return something, so I can say I create the right, and then I can say return. All right, and then that's that. Okay, so this is there are two approaches. One is a more verbose style, which has a more syntax to it, and then there is a minimal syntax approach as well. Okay, so this is a more verbose style. So you usually do not need to write that much of a syntax, but first we will cover that. And then there is another approach as well, where you can, and I'll cover how you can avoid this syntax and in what scenario you can avoid this syntax. Okay, So now you would see, you would be observing that in the second implementation scenario, and both are same Lambda expression implementation only for our supplier interface. But in first case, there is a more of syntax like closing, opening and closing curly braces, and then the return statement is there. But in the second case, just the mega arrow and the formal parameter section is there. But then we are returning the value directly, right? We are not using the return statement, neither we are using the parenthesis, curly braces. So why is that? So the rule is that if the body of the lambda expression, which is enclosed in these curly braces, does have only one valid Java statement, then we can avoid the curly braces. Okay. But if it have multiple Java statements, okay, then we need to mention the curly braces to define that, okay, where does our body of the lambda expression start and where does the body of the lambda expression end. So it is intuitive enough to infer, right? That in what case we can avoid the parenthesis and the return statement if needed, and in what scenario we cannot. So like I mentioned, if there is only one statement, then the JDK is smart enough to figure out that, okay, this is the body of the lambda expression because only one Java statement, right? So we can avoid the curly braces. And if there is a return value expected, then the return type as well. But if there are multiple Java statements written in the body of the lambda expression, then we need to mention to the JDK that, okay, here our body of the lambda expression start at the beginning of the curly brace, and here at the end of the curly brace, our body of lambda expression is ending. Okay. So in the current scenario, both the lambda expression implementation, this as well as this, are having one return statement only, which is a one Java statement, right? So we can avoid this curly braces and the return statement as well. Okay. And again, then there is a one more consumer interface. Okay. So if I open the documentation and show you the method signature of the method in the consumer interface, so it has a accept method, like you can see here. See, so this consumer interface, this is a functional interface, and it is part of Java util function package. And mostly all of the functional interfaces which the JDK has defined are part of this Java util function package only. And the method signature here is something like the accept method. It takes one parameter, which is of T generic type, and it do not return anything. Okay. And another thing to note is a functional interface could optionally have an annotation like this at the rate functional interface, but it is not mandatory. It is just we are saying to the compiler that, okay, we want this interface to be declared as functional interface. And in case we are not violating the definition of the functional interface, then the compiler would give error and tell us that, okay, you are not writing a functional interface. But even if you do not mention the annotation at the rate functional interface on the functional interface, then, and as per the definition, if you have implemented correctly, then it is not mandatory that only if you define the mention the annotation, then only it is going to become a functional interface. Okay. Okay. Now coming back. So like I mentioned, it have only one method which takes an argument and do not return anything. So what I'm going to do is, like I mentioned previously, we are first going to mention the copy the formal parameter section. So let's say the generic type would be string type. So the accept method would take a type of string. Okay. And then we write a mega arrow. Okay. And then in the parenthesis, we mention what we want to do in the body of the lambda expression. So let's say whatever is passed to the accept method, I just want to print it. Okay. All right, right. So this accept method is there. So it takes one parameter and it does not return anything. And with the help of the lambda expression, we are doing going to provide the implementation of this accept method. So what we do is we copy the formal parameter section, which is this part, right? And because it is a generic type, so we mention what type it has to be. So we mention string as, then we write our mega arrow, and then we write the body of the lambda expression here, right? And we just want to print it, so we mentioned it. So this is a more verbose style, right? So, and because now observe that the parentheses have curly braces and close only one Java statement, right? So like I mentioned, we can avoid these curly braces, and we could avoid this semicolon and all to write it in a more cleaner syntax. So what I could do is I could just directly mention it in a minimal syntax style like this. And obviously this I need to mention. Okay, so that is there. So now let's try to run this. So see, when we are invoking this implementation of the supplier here. So we have our implementation of supplier. So we do supplier.get. So it would return us this a return value less verbose, right? Because we overwritten the first implementation, and we print that string. And another implementation we have here of consumer. So what we mentioned in the body of the Lambda expression implementation is we mentioned that, okay, we just want to print whatever is passed to the accept method. So we passed consumer.accept hello, and then same thing is printed here. Okay. And like I was mentioning that uh, a body of lambda expression could have multiple statements also. So what I mean is, let's say I can write one more statement here, and it would be string dot to uppercase. Okay. So now see here, in this case, I have mentioned two Java statements, right? Two system.out.println statements are there. So in this case, if we want to convert it to a minimal style syntax, which is mentioned like here at this point, line number 26, so we cannot do that, right? Because there are multiple Java statements. So obviously we need to mention the start and ending of the Lambda body. Okay. And then, so that's why we need to mention the curly braces here and as well. And another point to note is that here we are mentioning the type of formal parameter, right? String S, okay? But it is not mandatory, okay? We can just write simple S, okay? Like here we have mentioned S only, right? We have not mentioned the type of the formal parameter for the Lambda implementation. So in what scenario we can avoid it is, so see here, the target type is mentioned for the this consumer variable is a string only. Okay, so here it is able to infer automatically that type of this S variable is going to be string only. So even if we avoid this mentioning this data type of this S variable of Lambda implementation, then also it is fine. But these things you can, as and when you practice and when you starting more and more lambdas, it would become the second nature of you to avoid all these unnecessary syntax, and you would be writing a more minimal syntax style. But from at the beginning, you could start at more verbose style so that you are good with the concepts as well. And then you can at later stage, you can leave this syntax. Okay. Any questions till this point? Anything? And I hope now it is a little clear also. My audio feedback. No questions? Okay. So we saw some code examples, and then we have this Jdk Toolbox for today. Okay. So like I was discussing that in JDK, there are 40 plus more than 40 plus functional interfaces which are defined, and 40 plus is a lot of functional interfaces. But conceptually, just to grasp and just to understand the overall, these all the functional interfaces which are defined here are basically divided in four categories: supplier, consumer, predicate, and function. So if we are going to discuss that, so that you have a overall understanding on uh, to know that when to use which functional interfaces, because every now and then when we are going to you are going to write the functional code, and then you do not want to write your own functional interfaces if they are already available. And trust me, most of the requirement which you are going to have for them, there would be already a functional interface. Only in niche case scenario would be writing your own functional interfaces. So let us discuss few functional interfaces, most commonly used functional interfaces. So the first one is supplier. So the declaration of the supplier interface looks like this. It is a generic type interface. It has only one abstract method, like we saw, get method, and it returns a type. So it is used to create the data source, or it is used in when we are implementing a producer, or when we are implementing a source of data, right? So then we implement or use the supplier interface. Okay. Next is the consumer interface. So like the name says, it takes an argument and it does some processing on it, and then that's it. Okay, so it takes an argument and it processes that argument and then doesn't return anything. So it acts as a sink of data. Okay, so you might be wondering with the terminology which I'm using, the source of the data, the sink of the data. So we'll come to that. It would make more sense why we are doing it. And then there is a predicate interface which takes one argument and it acts as a filter over the data. Okay, so it takes the data and returns a boolean true or false value on depending whether it accepted or did not accept the data, right? So that is there. So it acts as a data filter. And then there is a function interface which which is a generic functional interface with the two generic type parameters, t and r. So t is the input type which this, or the formal parameter type which this function is going to take, and r is the return type. So it is a mapping or transformation operation. To implement those, if we use it. Okay, so it takes something, it does transformation or mapping operation or some processing over it, and then it returns the result. Okay, so it is used either for the mapping operation or the transformation operation. And then there is one more. It is not from the Java 8 or the function package, but it comes under the definition of the functional interface, the runnable interface. If you have worked on the threading and multi-threading, you may be already familiar with it. So there is only one method, run method. It doesn't take anything and doesn't return anything. Okay. But one thing to note here with this runnable interface and this being a functional interface is that, so you might already be aware that runnable interface is an interface from long back, from even from the days of the Java JDK 2 or JDK 3. Okay, so what does mean? It mean is the definition of the functional interface is such that it is not mandatory that only the functional interfaces which have been part of the JDK from and after the JDK 8 are could be considered as functional interface. Any interface having only one abstract method can be considered as a functional interface. And what does it mean is, let's say you have an old code, okay, old legacy code, which is which has the implementation of this runnable interface. Okay, so because it is a legacy code, it would have the implementation either as anonymous classes or as a normal class which is implementing the runnable interface and have a run method implemented for it. But if you move that legacy code and move it to Java 8 or Java 8 plus, then on the same runnable interface variable, you would be able to write the Lambda expressions, okay, without changing your code drastically. So what it says is Lambda expressions have not been backported before Java 8. But yes, if you uh, upgrade the version of the Java for the legacy code to Java 8 or Java 8 plus, then very easily you would be able to replace the code snippets where you have implemented the either anonymous classes or the normal classes for the functional interfaces to the Lambda expressions. All right. Now, for the terminology which we use to define these four basic interfaces here, the supplier, consumer, predicate, and function. So functional interfaces are mostly used in the streams, and a stream could be said as a continuous flow of data, right? So try to make sense here. So supplier acts as a source of data, then consumer act as a sink of data, okay, predicate act as a filter for the data, and the function acts as a transformation or the mapping operation for the data. So it is like a stream or the flow of the data, and these all components are fitting almost intuitive very well intuitively in that stream of data, right? At the beginning of the stream there is a source of the data which is supplier. In between there are and in between there are filters or the transformation operations, which is predicate implementation of predicate or function, and at the end there is a consumer or the sink of the data, right? So that is how it is uh, designed conceptually. Okay, so given that we have discussed this, now we'll like to see some implementation of these functional interfaces which we just discussed. Okay.
So all these four interfaces are predefined interface.
Yes, yes. So like uh, show on this consumer interface, right? Java util function. So this is the package which you can remember, Java util function. In this package, all these functional interfaces are defined. Okay. And these four are the major category, logical category, in which all these functional interfaces come. See here, there are a lot of these functional interfaces, right? But logically, these are four only, right? So if you see, we already saw consumer, right? But then there is a by consumer, right? We already saw function, right? But there is a double function, double consumer, double supplier, right? So what I'm trying to say is, logically, we have all four categories only: supplier, consumer, predicate, and function. But then there are variation of these, right? According to the return type and according to the number of the parameters that they can accept, and according to the whether they are generic type or whether they are working on the primitive types. So giving with that combination, there are a lot of. more than 40 plus functional interfaces. But if you just want to summarize and have an overview
So how
over the
will we know
concept,
like
what it is.
what are all the methods to override? I mean, whether that is in supplier or consumer.
No, so that's what I'm trying to say, right? So supplier acts as a source of data, right? A producer of the data. So you want to see that, okay, what I want. Do I want to produce the data? Does my Lambda expression need to act like as a producer of the data, right? Something, it acts as a creator of the data. Then we need to implement the supplier, right? Do I want to filter the data? Then we implement the predicate, right? And do I want to consume or process the data and then do not want to return anything? Then we implement the consumer, right? So like that. It will be more clear when we see the code examples. Okay. Okay. So here we'll try to see few of the examples. So let's say we create a list. Okay. A normal list we created with the string uh, um, instances 1, 2, 3, 4, and 5. Okay. And then there is this predicate interface. Okay. And for this predicate interface, we are writing a lambda expression here. Okay. So now if we go back and we see that what this predicate interface is. Okay. Okay. See, for the predicate interface as well, like I was saying, all these conceptually work like the same only. This is a predicate interface, but then there are variations. There is a long predicate, there is an int predicate, there is a double predicate, and then there is a by predicate. So like I mentioned, the predicate interface acts as a filter. Okay, if you want to filter some data, so you pass the data and then it returns the true or false in terms of whether it accepted the data or not. So what does this long predicate would do? It works for the input data type long. Int predicate would take accept the int as the input data type. Double would accept the double. By predicate would take the two types, right? One of type T, another of type Q, like that only. So if we go to this predicate interface, so if you go to this abstract method section, you see. So what method it has? It has test method, okay? And the test method is supposed to get one type, uh, one parameter of generic type, and for that it needs to have an implementation which we are going to provide, okay, which acts as a filter that whether we accept this data or we do not accept this data. Okay, and accordingly we return true or false
What type
value.
of data? Sorry, what type of data is it? Boolean. Okay.
Right, Boolean is a returned value, but what kind of data we want to do the filter operation, that is a T type, right? Because it is a generic type, right? So a user can define whatever types he want to use, right?
So it can be string, int, anything.
Yeah, string, int, or your user defined user class, or let's say employee class, anything, right?
Okay.
Okay, so now like in our case, we created this list, right? So the type of this list is a string only. So in our case, that generic type for us is string. Okay. Okay. And now
Okay.
what we want to do is we want to apply the filter operation on this list. Okay. So what our filter operation says is that I want to filter or remove all those string instances which start with the letter T. Okay, so this is a basic filter operation, right? We want to remove all the instances in this list or the elements in this list which start with the letter T. So how do we define that operation? So we define this operation like this. We mention the predicate string. Okay, it is going to accept the string data, string type elements, and then we write the name variable starts with the T. So like I mentioned, we first copy the formal parameter section, which is here we go, which is this T in our case, and because it is a string, so we write string and then the T, right? So we write string, and like I mentioned, we have avoided the data type here, but we can mention as well. Okay, so we just copied the formal parameter section, then we write the mega arrow, and then we write the body of the lambda expression. So on this string, what we are saying is its string starts with the T. Look, okay. If it doesn't start with the T, it returns true. If it starts with the tree, it returns false. Okay, and then we'll see how it would do the filter operation, right? So this list has a remove if operation, right? And what does this remove if operation takes?
What
This
is that
remove if operation,
not string dot start with T?
right? So string dot start with the T, it returns a Boolean value. String dot starts with the T, right? So if it starts with the T, it returns true. If it doesn't start with the T, it returns false, right? And when we are negating the expression, so it is a reverse of it.
We have
If it's
written like not, right? Not string, that exclamation mark,
yes,
which means string which does not start with T.
yes.
Okay.
So if it does not start with the T, right? So let's say, consider it for this element, okay, 1, okay. So if we pass
Okay.
this element here, so if we pass it here, so it says 1 dot starts with T, okay. But, and what it would return? It would return false, right? 1 dot starts with the T, it would return false. And when this false goes to this negation expression, so this false is converted to true, right? Which means we have accepted this element, right? Because
Okay.
when we say true, we accept this element, and when we say false, we discard that element, right? And what we discussed earlier, that we want to discard all those elements which starts with the T, right? So that way, what we are trying to do, okay? Okay. So given that now we have implemented our lambda expression here, okay? So we can pass this lambda expression to another method as a formal
Sorry,
parameter
can
or
you
as an
explain
argument,
it
okay?
once more with
So
the
then,
example? I'm sorry. So
okay.
if when the value 1 is passed, so the string dot start with T, it returns false, right?
Yes,
So when that not symbol, with that not symbol, so it is returning true. So in that the start with T
yes,
variable will have true. What about the
yes.
next step?
No, not this start with the variable is going to have to. This start with the T variable is holding this implementation of this lambda expression, okay? At this
Okay.
point, no value is passed. This code is not executed at the line number 16. At line number 16, we just have defined our lambda expression, okay? And this lambda expression would execute at line number 17, okay?
Okay.
See, uh,
So
this
how
is
that is
the
working?
expression
That's
which
my
we
question.
implemented.
No,
Yeah,
suppose
yeah.
yeah, I just wanted to know like how the for 16th line and the 17th line is working. Like when 1 is being passed, the first value is 1. So
Oh,
how is it working? I can't understand that.
okay. Let me go to the more simple example. Okay. So just forget the list for a while, and if we will see how we want execute this lambda expression for one value first. Okay. So
Okay.
start with the T, Now, the name of the method in the predicate is test, right? So test, and what we pass here is, we pass here 1. Okay. So now this test method would return a Boolean true or false, right?
Okay.
Okay. So let me print it.
So when it will return true and when it will return false?
So in
I mean,
case
what
it
condition?
starts with the T, it would return
True. Okay. But
in case
my
it start.
okay, my doubt is that
Yeah,
not.
yeah.
Okay.
Okay. So okay. So with the not, you are confused, right?
Yeah.
Okay. Okay. Don't worry. So first consider what we want. What is our requirement? Okay. Our requirement is that if we pass any string, okay, which starts with the T, right? Then
Okay.
for that it should return false. That is our requirement. If it starts with the T, then it should return false. Okay,
Okay.
that is our requirement. So as per
Oh,
that,
okay. Now I
our
got it.
code has to be okay.
Okay. I thought when it's starting with T, it should return true. Why is it returning false? So that was my question.
Yeah. Yes.
Now I
Yes.
got
No
it.
issues.
Okay. So when the value
Okay.
is false, it is removing.
Yes. So it when we use the collection framework. And so in the collection framework, there are various methods which are there where you can inject the Lambda expression. Okay. So we'll see that how it is helpful to write the Lambda expression. So at this point, we created the implementation of our Lambda expression, right? So this much you are clear, right?
Okay.
Okay.
So here
And
I
at
wanted
this
to do
point,
a filter function. So I'm using predicate.
yes, because a filter operation is basically and boils down to this only, right? That you do an operation on some data, and for then on that operation you only have two values, either true or false, right? And then those true values are considered as filter, right? If it is true, that data is accepted. If it is false, that data is discarded, right?
Okay.
So that filter logic we encapsulate in the implementation of predicate in the form of Lambda expression. If you step aside from Lambda expression, you could do with the normal straightforward class implementation as well, right? Because see, this is an interface, right? Normally what you would have done, you would have created a class for it, which would be implementing this predicate interface, right?
Okay.
And then your class would have this test method, right? And inside that test method, you would have written the same only, right? That
Yes.
string dot if it starts with the tree, and then you would negate the expression, and then you would return it, right? And then
Okay.
you would create an object of that class, and then on that object of that class, you would call this test method, right?
It would have been good if we have both. I mean, with the without
Okay.
lambda and with lambda, then you would have understood it
Okay,
very
sure.
clearly.
Okay, sure. So let me do it quickly. Okay, so this predicate is there. Okay, so let me create a class here which does the same thing. What do I write here?
Suppose if it is a whole lot of list, then we have to pass everything there.
Sorry, can you say again?
Because we have 5 items in the list, then we have to pass like this test of one you have given, right? So in that we should pass all for the whole list.
Yes, we do not need to pass the whole list. On the list, we have in the list collection, we have the method itself where we can, in case of the Lambda expression, we can pass the Lambda expression directly. And if we are working with the classes, not with the Lambda expression, then in that case, we need to iterate over the list and pass one by one value, right? Like we can for loop, we can traverse the list and then take one by one value and then pass it to this, okay?
But now we have passed only one.
Yeah, just to showcase, okay? Okay, so for one string element, it works like this, that in case of non-lambda expression, how it will do is, we took the predicate interface, we made the implementation of it. So there is a test method, then it has a single formal parameter. We take that parameter, and if it starts with the t, then we return false. If it do not starts with the t, we return true, right? Then what we do, we create the object of this class, and on that object of class we call object.test, and we passed our string element 1, right? Right. So if the same requirement, if we want to achieve through the lambda expression, then what we do is that at this point here, we first implemented this lambda expression. So basically what you can say is, in this much of the syntax, this much of the boilerplate code, you replaced with this one liner, okay?
Okay.
That you mentioned that, okay, for this predicate interface, I wanted to provide the implementation, and the implementation, the body of the implementation is this, okay?
Okay.
Okay, so you see some benefit, right? That you are writing a less and less of code, and it is more minimalistic in approach, right?
Yes.
Okay, and now you might be wondering that there is one more intuition behind it here. If you see that, then it would be easier to understand. So what it is that, see, this predicate interface, like I mentioned, has only one abstract method, right? And that is a test method, right? Right. So
Yes.
let's say if this predicate method has multiple abstract methods, right? Then there had to be requirement that when we write a lambda expression, the JDK has to be told that for which abstract method we are providing this implementation, right? But like the definition of the functional interface says, it can have only one abstract method, right? So there is no need to tell that for which abstract method it is there, this implementation is there. Obviously only one abstract method is there, so we are providing the body of that only, right?
Okay. Yes.
So that's why we are able to have this minimalistic syntax, right? Because we are trying to avoid the obvious code which we are writing, right? Like in case of this class implementation, we already know that only one method is there, and only for that we are going to provide the body. Then why bother mentioning redundantly that this is the class, this is the method, and for that we are writing the implementation, right? Why not say it that this is the predicate interface and this is the body for it? For which method we already know, right? Only one method, so for that we are having the body, right?
Okay.
So that's how the Java says it, that okay, we are trying to avoid the obvious code and then the reducing the syntax, right? Okay, so given that, here we have our implementation of lambda expression. And in case of the lambda expression also, the way of invoking the lambda expression and way of invoking an object of class is same. So see, object dot test, and we passed the string element, and starts with t dot test, and we passed the element. So the way of invocation is same only, it's just the implementation has been different, right?
Yeah.
And both the implementation, class implementation and lambda expression implementation, would return the same thing only, right?
Yes.
Okay. So now, given that we were discussing with the list, like if we have this list of string elements and then we want to do the filter operation, then how would we do it? Okay.
Okay.
So this strings list is there, and then there is a remove if method in the collection framework. Okay. So if you
So
go
that
here,
does when the value is false, it removes.
yes. So how it works is, you see, this remove if method takes a predicate, implementation of predicate, right?
Okay.
So
Okay. Okay.
in this, we are mentioning the implementation of a predicate, which holds our encapsulates our logic, right? This filter would encapsulate our logic, right? And then what this remove if method, which is a part of collection interface, what it would do on our behalf is, it see, it takes the iterator, right? It takes the iterator over the list which we have provided, or over the collection which we provided, and each dot has next, which means it iterate over all the element, and then it do, see, this is the filter which we passed, and it invoke filter dot test each dot next. Okay, and if it returns true, then it invokes each dot remove. Okay, and removed is equal to true, it sets. Okay, and if it doesn't, if it returns false, then this would not go into this if section and it would not remove it, right? So basically what it is doing is, it is iterating over the list, one by one element of the list it is passing to our filter, right, at this line. And then if it returns true, then it removes that element from the list. If it doesn't return true, then it does not remove that element from the list.
But we
Got it?
are sending false, right? When it starts with the T.
Yes. So when it starts with the tree, we are sending false. Yeah, then it is the other way around. The all the elements which starts with the tree, they would be preserved, and the rest of the elements would be removed.
But our intention was to remove the word which starts with the T.
Yes, then we should remove that negation expression. Sorry for that.
Yeah, that is where I got confused. I didn't get that point.
Yeah. Okay.
So we should
So
know
this
this
is
remove if, yeah, I mean, what is implemented inside remove if, then only we'll be able to use that method.
yes. So first we have to familiarize ourselves with the retrofitting of the collection framework or whatever APIs we are using, which accept the Lambda expression, that what they are accepting and how they are behaving for the different, the response, the true value or false value, right? So we can easily look out in the either the documentation, or we can easily look out the code as well. But looking the documentation is more helpful, right? Every time we cannot go and read all the code, right?
Yeah.
So
Yeah.
like that, we can look the
Whenever
documentation.
it is needed,
What,
we can see the documentation.
yes, yes. And then we can pass our implementation. So we'll know what implementation to pass. So like in this case, we know that we need to pass the predicate, right?
Okay, yeah.
Yeah.
So
So
basically, this is used when we migrate the code from the lower version to higher version.
yeah, either you can say that we migrate the code from Java 7 or previous to Java 8 to Java 8 or Java 8 plus, right? Or we are working either from Java 8 or after Java 8. Then more or less we try to write Lambda expressions and functional style of code because there is a benefit to it, right? Because we need to write less and less of code, right? And it
Okay.
is a more readable also. And when we'll come to the next stage, that learning about the streams, then you will realize the benefit also, that uh, what we could have done with just a single line, for that we would be writing 5 or 6 lines or 10 lines of code without the Lambda expressions and without the stream API. Okay,
Okay.
so it's not the syntax style only. It is a less writing of code and more readable code also.
Okay. So it's possible, multi-line.
Yes,
Okay. Can we see the output for this program
yes, sure.
with the not and without not? First, let's see.
Yes, sure. So this one is this. So line number 13 output is the first one. So when we pass 1, it says true. Okay. And then this is the line number 24 output is second. So that is also true. And then there is a strings dot remove if starts with the T. So it has removed. And then
The other
strings
without
we have printed.
T.
Yeah.
We
So
need to
see
remove that
all
not.
the, yes. So all the elements, string elements, which starts with the tree were preserved and the rest were removed, right?
Yes.
So let's say if I remove here, then it would be other way around. Okay.
Yes.
Okay.
That's what I got confused. Okay. Anyway, thank you.
Yeah. So, and then we have the another. So till this we discussed that, okay, we want to filter the elements from the list. So we mentioned the predicate, but then we didn't see this, that, okay, how we printed the list. So we didn't iterate the list usual way. So see, at this point, strings dot remove with, and then start with T. So we are passing this start with the T implementation, and as per that, this elements in this list have been removed, right? Now this list contains new set of elements, right? Some of it which were earlier there have been removed. Now how we are printing this list? So see, like I mentioned, there is a consumer interface. And if you remember what this consumer interface logically says is, it acts as a sink of data, right? That it takes some element, it process it, and then that's it, right? And our requirement is that we want to print the elements of list, right? So our requirement is also acting as a sink of data, right? That data comes to us and then we process it and then we leave it. Okay, we are not passing the data to the next stage, right? So what we do is we take this consumer interface. Okay, so what this consumer interface says, let's see, it has only this one accept method, right? And then there is a default method as well. But like I said, a functional interface need to have only one abstract method, and it can have any number of default and static methods, right? So it have one abstract method. So yeah, it is a functional interface, and the annotation also is there, which is optional. Okay. So now if we want to provide the implementation of this consumer interface, what we need to do? We copy this formal parameter section, then we write a mega arrow, and then we write the body of it. So we copy formal parameter section, which is string. Okay, that okay, it is going to accept the element of type string. And then what is it is going to do with that element? It is going to print that element, and that's it. Okay. So this is our list. Strings is the list, and it has a for each method which accept the consume. It takes the consumer. Okay. So now if we go and see how it works is, so in this action, we mentioned that we want to print the element, whatever element which is being passed. Okay. So basically what we did is in this accept method, we return system.out.println and t. Okay. And we passed that logic to this for each. Okay. And then what this for each would do is it would, with the help of this for loop, it would iterate over all the elements in the list, and one by one it will pass those elements of the list to this accept method. So action.accept nt. And what our accept method is doing, it is printing whatever is being passed, right? So for each and every data element in the list, it is acting as a sink of data, right? We are doing some processing and then leaving it. Okay, so we provided the implementation of the consumer, then strings.forEach, we pass that implementation. This is out implementation, right? And because of that, we are printing the list here. Okay. This list, at this point, this list is printed, right? So this is printed because of this line, line number 29. Okay. And then there is a less verbose style. So you notice here, right, that at every point when we are implementing the Lambda expression, right, we are defining the Lambda expression, we are especially explicitly creating this variable, right, that predicate string, consumer string, right? But that is not necessary. Why I'm saying is because, see, this string dot remove if, right? Yeah, this this accepts a implementation of type predicate. So it is not necessary that first we create a variable, then we provide the Lambda implementation, and then this variable we pass here. Okay. Instead, as and when you are more into practice and more familiar with the Lambda expression, such minimalistic and such less verbose or least amount of code you would be writing, that inside the remove if directly you would be passing your body of the Lambda expression, right? String, and
So we
string
don't want
starts
that
with the
line,
T.
line number 22.
Yeah, no, this is just to be more explicit and to show you in the first hand when we are just starting with the Lambda expression, right? Because anyway, indirectly what we are doing, we are passing that starts with the T variable to the remove if, right?
Okay.
So we can pass the body of the Lambda expression directly as well, right? Why? To be more explicit and more write more line of code, right?
That's what. So we don't want that line.
No, that is to just to make us understand and make us see that how this is done step by step, and then how we can remove this unnecessary step and end up with the minimal code, right?
So suppose if we are passing integer value, then we will mention as predicate. So in the generics, we'll mention as integer after
Yes.
predicate.
So no. So this string is just a name of the variable. It is not a
No,
data type. Okay.
that is not the thing.
Uh,
The line number 22, I'm asking.
yes. So
So in
like I
the,
mentioned, yeah. So let's say if it was a list of integers, right?
okay.
So
Suppose we want to remove the
then
even numbers, something
yes.
like that.
So then what would have happened is, because it was a list of integers, right? So if we go to this remove if, and if you see here, right? So this is accepting here for a while predicate of type string, right?
Okay,
You
so
see?
only if it is type string only, we can do this. I mean, use this here, remove
Yeah,
if.
yes. If it
So
was a
for
list of integers, then it would be accepting predicate of type integer, right?
yes.
Yes. So then we would have passed the predicate of type integer. So then it would have said, let's say if you want to filter the even numbers, that you want to remove the even numbers. So you would do something like, uh, let's say element E, and if E mod 2 equal to 0, something like that, right?
Because there, can we write that with one line? We will not be able to write.
Yeah, we can do it. Let us create a list quickly. Okay, so we have this list of integers, and then we want to filter nums dot uh, remove if, right? Nums dot. Okay, and so element E, whatever element is should be passed. Okay, and then element mod 2 equals to 0. Okay, and then we do nums. Okay, see 1, 3, 5, 7, only odd numbers are there, right? So because it was a list of integers, so the predicate also which we mentioned, that is also for
What
the
is this ELE?
integer type only. ELE is, so if we go to this predicate definition, right? So there is this test method, right? And it takes one formal parameter or one argument, right? And then
Okay.
there is this t variable, right?
Hmm.
So it's just that instead of writing the variable name as t, I am mentioning as a ELE. Okay. I mean, I need to mention the name of the variable, right? In which I would be receiving the input, right?
So we
So
don't
that
have to
name instead,
initialize that. We don't have to mention anywhere that directly we can write ELE.
yeah, directly we can write TLE because this and the type we do not have to mention because it is already self-obvious that because the uh, this as per the list, the type of the variable is going to be integer only, right?
Okay,
So
okay.
the type of element ELE is going to be a type of integer only. We can mention it explicitly. There is no error in that. Okay.
Okay.
See. Okay. So if you want to mention explicitly, you can, but as per the target type variable. Okay. So if you hover over here, the target type variable, from target type variable, it is clear that the ELE is going to of type integer only, right? So the type inference would happen. And because of the type inference, we could avoid explicitly mentioning the type of the variable. Okay.
Okay.
Okay. So we covered the predicate, we covered the consumer. Okay. Let us see if we have more examples. Okay. So let's see some mapping operation. So there is a user class which I have created. Okay. So a basic Pojo class, right? Name of the user is there and okay. and then the getter setters of the user are there. Okay, so we have 4 users, Sarah, James, Mary, and John. And then we have the list of user here. Okay, we added those users to the list. And then we have another list of type string. Okay, now what our requirement is that we have a list of user objects and we want to convert the list of these user objects into a list of string, and each element of this list would contain the name of the user. Okay, so it is basically a transformation operation or a mapping operation, right? That each user object is mapped to a string object, which is the name of that user, or each user object is transformed to a string object, which is the name of the user, right? So a mapping operation. And how do we do that? So we do it with the help of this function interface. So again, what does this definition of this functional interface looks like is, this has one abstract method, this apply method. Okay, so this apply method takes t and returns r, which means it takes one data type, t data type, and returns r data type, right? It transforms this t data type into this r data type, and in our case, what these t and r are going to be, for us the t is going to be user data type and r is going to be string data type, right? Okay, so function accept the user and return the string, which is the name. So we write to name, this is the implementation. So it takes the user, okay, mega arrow, and the body, what does the body do is user dot get name. That's it. Okay, so this is our implementation of the function interface. Okay, and it is acting as a transformation or mapping operation. So what we do now is we iterate over the list of users. Okay, and there is this to name dot apply user. We get the string name of the user, and then the names dot add name. Okay, so this is a more verbose style, more syntax. Okay, we are writing a lot of code just to understand that how it would work. Then we can write the straightforward way also, right? So then, and then we print all
What
the
is the thing we are
users.
doing here? We are just adding the name. I don't understand.
See, we have two lists here, right? One is a list of users, okay?
Okay.
List of user types. And then there is a list of string, okay? Which is an
Okay.
empty list for a while. And what we want to achieve is, we want to convert the list of user into list of string, okay? And at the element level, each string would represent the name of the user, okay? So basically, in each element of this user's list, we want to take the name out of it and put it to this names list, okay?
Okay.
Okay. And this implementation helps us to get the name of individual user which we pass to it, okay? So whatever user you pass to it, this implementation or this functional interface lambda expression would return us the name of that user, right? So if I pass Sarah into this to name, then it would return the name of the Sarah. If I pass James into it, it would return the name of that user James, okay, as a string. Okay,
Okay.
so now I iterate over this users list. I passed each and every element of that users list user, right? To name dot apply. This is to name, and this has a apply function which we implemented just here. So we pass it and we would have the name, and then that name we are adding to this names list. Okay.
Okay.
Okay. So, and then we have this users list, we print it, and then we have this names list, names dot for each. Okay. And then we print that as well, right? So let us see. So this see. At line number 26, we printed the users, right? So users, all the users are printed. And at line number 29, we
If you
printed
want
just
to
the
do,
names.
if you want to print,
Yes.
then we need to use the consumer interface.
Yes, you can use the consumer interface as well, or you can just directly do the iterate over the list, like here we are iterating over the list, right? So in the body of this for loop, we can write system.out.println as well. But here we are more and more trying to find the opportunity to use the Lambda expression, right? So print a logic as well, we are
So
trying to achieve through the consumer only.
function is basically used for
Mapping
conversion from,
operation. Yeah,
sorry?
conversion you can say.
Conversion operation.
Yes, yes. To converting
From
one type into another type.
type. Okay.
Okay. That you have some type, you do some operation, you do some processing, and then you convert it to another type. Not necessarily another type. You can convert it to same type as well, but you did some processing in between. Okay.
Okay.
So that we wanted to demonstrate here, that how the mapping operation we can achieve through Lambda expression. Okay, we are clear here.
Yes, Kuldeep.
Okay. I think we are going to be short on time, but let's see how much we can cover. Okay, so we'll summarize what we discussed. So till this point, okay. So we had the supplier, which was acting as a source of the data. We had the consumer, which we could use as the sink of data. We had the predicate interface, which acts as a filter or for the stream of data, right? And then we have the function interface as well, functional interface as well, which acts as a conversion or transforming or mapping operation to represent those. Okay, right? So, and these are the methods which are there in these functional interfaces. Supplier has get method, consumer has accept method, predicate has test method, and function has apply method. Okay, and here I have mentioned some illustrative Lambda implementation for each of it. Okay, just to have a quick glance over it. Okay. So now we just want to discuss a little bit about the performance of Lambda expressions. Okay. So like what we should remember and what we should be careful about to have the use the Lambda expression and have the best performance out of it. Okay. So the question is how fast the Lambda expressions are, right? It should just not be about the writing minimal code and more cleaner code. There should be a point of performance also, right? Because more or less that is the ultimate goal, right? Once we have written the code. Okay.
Yes.
So right. So when I started this course, where I told you that the Lambda expressions are not same as instances of anonymous class, right? And I'm certainly not going to tell you the contrary now, but whatever we can put into the Lambda expression, whatever we can write into the Lambda expression, we can write in the anonymous class as well. You're familiar with the anonymous classes, right? So a little bit maybe. So if I go back to our example, not this, yeah. So this is the class implementation of the predicate, right? This is the Lambda implementation of the predicate, right? And then there is an anonymous class implementation of the predicate as well, which is, you might already be familiar, but I just want to show it that okay. Okay, so see, here we created the whole class just for the implementation, and then we created the object of that class to invoke our logic, invoke our test method. Okay. In case of the lambda expression, we directly mentioned the implementation of the lambda expression, and then we invoked that lambda expression test method with the help of lambda expression. But here, see what we are doing. Neither we created the class nor we created the lambda expression. We are creating the anonymous class here, right? A class which do not have a name, right? So we are creating the anonymous class here directly. And then in that, we are providing the body of the method, implementation of the body of the method, right? So what I'm trying to say is, whatever we can mention in the lambda expression, we can mention the same thing in the anonymous class as well, but not the vice versa. Whatever we can put in the anonymous class, not necessarily we can write it into lambda expression as well. Why? Because an anonymous class, apart from implementing the interface, can extend the abstract class and a concrete class as well. But a lambda expression cannot do that. Okay. So given that, what I'm trying to say is that the bytecode or the internally the bytecode which the compiler generates for the lambda expression and the anonymous class is different. Okay. And if the bytecode generated for the anonymous class and lambda expression is different, then that means the performance is also going to be different, right? So the lambda expression invoke a bytecode instruction, invoke dynamic in specific, which was used in Java, introduced in Java 7 specifically. And using of this invoke dynamic bytecode instruction in the lambda expression makes it at least 6 times faster than the anonymous classes, okay, in the computation if used properly. If you avoid few of the caveats, lambda expression is at least 6 times faster than the anonymous classes. Okay, if you do not understand this whole crux of bytecode generation and the use of invoke dynamic and then anonymous class, you can just remember this much, that at least lambda expressions are faster than the anonymous classes. They are more readable, their code is more minimalistic, and they works with the stream API, which is a feature in Java. Okay, so now there are few points or to remember and to avoid the performance hit when using or writing the lambda expressions. So the first is use the specialized functional interfaces when implementing and using the lambda expression. What I mean is that you may have seen that there is a that you are aware of the box types, right? That there is a int in primitive int in Java, and then there is a integer boxed types in Java, right? You are aware of those, right? That there is this integer and then there is a primitive int type as well, like something like this: int I equal to 10, and then there is this also integer IOB equals to 10, right? So this is a primitive type, line number 49 and 50. This is a boxed type. And for similarly for all the primitive types, like there is a int, there is a float, boolean, double, char, short, right? For all these primitive types, there are corresponding classes which we say boxed types, right? So when we say that, so what happens is you already be aware that then this int is passed to this integer, there is a underlying at the under the hood, there is a auto boxing happening, which means this primitive type is converted to the object type. Okay. And when we write something like this, and I equal to IOB. Okay. Sorry. Okay. So when the primitive is put into the class type, auto boxing happens. And when the class type is put back into the primitive, then the auto unboxing happens. And this process of auto boxing and auto unboxing, that is converting of primitive type to object type and converting of object type back to primitive type, this process takes a toll. This process is an expensive operation. not when done once or twice, but when we are doing it multiple times or millions of times, then it takes a toll. And when you are going to see such scenario is, so you might be familiar with the comparator interface as well, right? So like something like this, right? So when we want to sort a list, right? uh, in the ascending order or the descending order, what we do is we have a list of integer, right? And we want to sort it. So we pass this comparator to this list, that list dot sort, and then we pass CMP, right? So like something like this. And inside the CMP, what we write is integer dot compare I1, I2. Or we write if I1 is greater than equal to I2, return if I1 is equal to I2, return 0. Or if it is greater than, then return positive 1, or else return negative 1. You are familiar with similar implementation, right? Sorting the integers with the help of comparator. So what I'm trying to say is, when you use this kind of comparator, and we use this integer box type, so let's say there are 1 million elements in the list. Okay, so what is going to happen is, when you use the integer here as the generic type instead of a primitive int, that then for each sorting each and element of that list, auto boxing and auto unboxing is going to happen, and that is going to reduce your performance of the lambda. So instead of doing that, what you should do is you should use specific functions, right? So instead of using a comparator of integer type, we should use the int comparator, which instead of integer here works with the int, primitive int specifically. So let me show it to you quickly, because we are at the end of the time. Primitive lambdas, not here. Creating comparator. Yep. Yeah. So see, comparator string, comparator string, not this one. String dot compare to somewhere I implemented it. Yes. See, so we have the list of string here, and we want to compare this each string element on basis of their length. So the string with the smaller length should come first, and string with more and more the larger the length should come at the end of the list after doing the sort operation. So here we are mentioning this comparator which accept, okay, and we are doing integer dot compare s1 dot s1 dot length and s2 dot length. Okay, we are comparing the length of two strings at a time, and that way when we pass this comparator to the string dot short, then it would eventually compare through using the same logic. It would eventually compare the whole sort the whole string, like strings dot sort and cmp1. Okay, but here the issue is we are using the boxed types or the object type for the primitive int, and that would cost us the auto boxing and auto unboxing. Now how we can avoid that is, okay, how we can avoid that, instead of using direct comparator, we can use the comparator dot comparing int, okay, which uses the primitive types. Okay, and comparator dot comparing int, instead of this uh, taking the integer, it takes the primitive int, right? And because for that only we are using this function here, which converts the which returns the primitive int, okay, instead of the boxed types. Okay. And that way we can avoid the performance overhead. I know I'm going little quickly and not explaining a lot till this point, at this point, because we do not have much time left. But you got my point, right? That whenever possible and whenever needed, instead of using the box types or class types for the primitive variables, use the specific functional interfaces which have the primitive types. Like in this case, let's say if I want to show you some example. So in case of the consumer, okay. So this is a consumer. This accept a generic type T, okay. And so accept T. So that means if we want to work with the integer, so it would have accept T integer here, okay. And integer would result in auto boxing and auto unboxing. So what instead we can do is we can use int consumer. So which already say that it accept int value only. Okay. So we do not need to use generic, and then we end up using integer, and then the auto boxing and auto unboxing happens, right? We directly use int only, right? And that way we avoid the use of auto boxing and unboxing, and that way we save the performance. Okay. You got it somehow?
So you mean to say that suppose if we know the generics, then we can go specific to that generic so that the performance will be good.
Yes. So
Okay.
just one thumb of rule. If you see yourself working with the data types which have corresponding primitive data types like integer having int, float having float, right? Then use go with the primitive data types only. If you see yourself which do not have primitive corresponding like user, string, employee class, then you go with the generics. There is a no performance hit over that. Okay.
Okay.
Okay. So that is for
So
the performance of the Lambda. Yeah, yeah, go on.
no, I just have a doubt whether like all these, this predefined interface, only those are like available. Like we also sometimes write interface. So will that be considered as as like uh,
Functional
wait,
interface.
yeah.
Yes, yes. So like I mentioned in the definition of the functional interface, right? Any interface having only one abstract method could be considered as a functional interface. So let us write one functional interface, okay? Quickly, let us see how we can write a functional interface, okay? So write a functional interface, give me something name of it, okay? Let's say my filter, okay? This is
Okay.
my interface, and then I write one abstract method in it. So it would return Boolean, and the name of the method is going to be test, and it would take a type of string. Okay, I'm not writing generic here. It would accept string. Okay, and that's it. Okay, so this is my functional interface. If I want to, which is not mandatory, I can write the annotation as well.
Okay.
Okay, this is my functional interface. Now, for this functional interface, I want to write a Lambda expression. Yeah, I can write it. Okay, so what is going to be my logic that if the length is, if I want to filter the string which has length of smaller than, let's say, 10, okay? So str dot length smaller than 10, okay? Okay, and that's it. Okay, and then let me copy a list from somewhere and try to execute it quickly. Okay. So we have a list here on length 3 is okay. So instead let me do 3 so that we have some output. So we have strings dot remove, then b. What happened? If predicate superstring in the type collection is not verified again, it's my filter. Okay, it needs to extend it, yeah, because it do not accept that. So we need to iterate over the list for ourselves only. Okay, and then this. Mm, okay. Nothing. b.test s. Okay. Nothing is smaller than 3. So see, whatever is smaller than 3, we are getting it. Okay. Because for whatever the smaller than 3, we are returning true. So we are printing it. And if it is more, the length is more than 3, we are not printing it. But you got the point, right? We can write our own functional interfaces. We can write Lambda expressions for them, and then we
Okay.
can use them. Okay.
Yeah, sure.
So we are past 12:30 here. So Nandini, do we have 10-15 minutes more? Because we have more, a little bit of content left, or you would like me to stop here?
I think it depends on participants and you. If both of you have time, I think you can go ahead. Otherwise,
Yeah, I don't
it's
mind. I don't mind, Nandini.
okay. Okay, then Kuldeep, I think you can continue and finish it off.
Okay, okay. So let's take 10-15 minutes more and try to cover rest of the content if we can. Okay. If anyone has any questions or want to discontinue, let me know. Yeah. Okay. So we covered the Lambda expressions. We covered how to write them. And then there is a chaining of the Lambda expression, which is a more of a advanced thing, and we would not be able to cover it. So let us cover the method references first. Okay, that's the last topic for us. So what the method references offer is, so we compared and we saw that mm, yeah, like we saw here that there is a way in which we can implement the complete class, and then we write the whole code, and then there is a way of writing the anonymous class, and then we come to the Lambda expression. So step by step, if we keep aside the performance for a while side, then what we are trying to do is we are trying to reduce the syntax more and more, right? And we want to write less and less of code. So that is the one of the motivation behind writing the Lambda expressions, right? So now, what if I say that in Lambda expressions as well, there are scenarios when in Lambda expression as well, we are writing the redundant code or more obvious code which could be avoided. Okay. And To address that only, there are method references. So what I'm trying to say is, we put back the classes and anonymous class, and we come with the more cleaner code, which is Lambda expression. And in Lambda expression as well, we address some of the issue with the when we are writing more code, and we come with the more short code, more cleaner code, which is a method reference. Now, in what scenarios we write method reference is, so let me open one of the example and try to see creating comparator. Okay. Okay. So let us consider this lambda expression. Okay. So this lambda expression is implementing this function interface. Okay. You remember this interface, right? So it takes something, it takes one type and it returns another type, conversion operation, right? So here what we are trying to convert is, we take the string type and we convert it to integer type. Okay. And how we are doing it is, so this you are already must be familiar, right? That how we convert string type to integer type by doing something like integer dot parse int. We pass the string and then it returns as the integer value, corresponding integer value for it, right?
Yes.
Okay. Yeah. So in our lambda expression also, we did the same thing only, that we take the string. Okay. So this function would have take the string and it would return the integer dot parse int. So basically, once to reiterate, what we are trying to do is, we have this apply method. In this apply method, we are writing here integer dot parse int. We pass t and what we return r. Okay. 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 So this particular line we pasted, see it as this particular line we pasted here inside this body, apply methods body, right? And then we return this, whatever is being returned by this parse int method, we return. Okay. Okay. Now, if you try to observe one thing, this is our body of lambda expression. Okay. Okay. Now, one question is, this body of the lambda expression contains only one thing, which is a call or an invocation to another method, right? Which is integer.parseInt. Okay. So what we are doing inside our lambda expression is, we are just calling another method. Okay. Which means our logic in itself does not contain any Java statement apart from calling an already existing method, right? So what we are saying is, when we are just calling another method, when we are not doing anything by ourselves, right? I mean, we are not doing this computation by ourselves in the lambda expression, right? That the logic of conversion of string to the integer, right? So we are just calling the another available method, right? So what we say is, then in that case, why to do this unnecessary syntax? Right? Why to write this unnecessary code that mention this string variable, mention this mega arrow, and then mention the name of the method which we want to call, and then the right semicolon and like all that. Why not? We mention just the name of the method which we are going to invoke. So what we see is, in the method references, we do just this. The name of the class, C, integer be name of the class we mentioned, parseInt is the name of the method, and that's it. So this whole syntax being converted to these two words only. Okay, make sense?
Okay.
Okay. So just try to observe one thing, that when the body of the lambda expression contains only a call to another method, in that case, that lambda expression can be converted to a method reference. Okay, we mention the name of the method, we mention the name of the class or name of the object to which that method belongs, and that's it. The rest of it would, rest of the code generation would be taken care by the compiler. It would do it for you. Okay, and you can just simply invoke, like you would invoke normal method expression, lambda expression, or a normal method reference or a complete class implementation itself, we would be just able to invoke it as str2int dot apply, because this function has apply method only, right? Like this dot apply. The invocation remains same. Nothing changes with the invocation. Only the implementation changes. From Lambda expression, we came to method references. Okay. So now internally, what would happen is it would be converted to integer dot parseInt. Okay. And inside this str, inside this parseInt, the str, actually this T type would be passed by the compiler itself. The compiler would generate the code on our behalf. Okay. So that we could have this much of the minimal syntax. Okay. Okay. So now we want to discuss, there are 4 types of method references. Okay. When we want to call a static method, then there is a method reference for that. When we want to call a method on an object, okay, not a static method, but a method of object on an object, data member. Okay, so not so data member, sorry, object. So then we have a method reference for that. Then there is one more scenario when we want to invoke a method on object, but we are not concerned about on which object that method is going to be invoked. It could be an arbitrary object, which is decided at runtime. Then there is a method reference for that as well. And one more, when we want to invoke a constructor, then there is a method reference for that as well. Okay, so let's start with the static method first. Okay, so let's say integer.parseInt, that is a static method, right? So how do we write a method reference for that? So what we do is we write like this: name of the class, colon, double colon, name of the method. Okay, so like this, integer colon colon parse int. Okay, like we did earlier in our code. So integer.parseInt, this is a static method. So name of the class, name of the method, that's it. Okay, now we want to invoke a method on particular object. Okay, let's say we have a string object, string s is equal to hello, and on this s object we want to do s.isEmpty or s.concatenate. Okay, on this s object we want to invoke isEmpty method. Okay, then what we do is we mention the name of the object and then the name of the method. Okay, instead of the name of the class and name of the method, we mention name of the object and name of the method. Okay, that on this as object I want to invoke this isEmpty method. All right. Okay, and then there is invoking a method on an object but of arbitrary type, which means the object on which the method is going to be invoked would be decided at runtime. So like this isEmpty and concatenate method are there, but these methods are invoked on this as object. But here we mention the name of the class and the name of the method only. Now on which object? These are not static methods. Compare to ignore case and concat are not static methods. These are instance methods. But we have just mentioned the name of the class here and name of the method, which means the object on which these methods are going to be invoked is going to be decided at runtime. How it would be decided, we'll discuss shortly. And then there is a constructor. We want to invoke a constructor of a particular class. So straightforward, like static method only. Mention the name of the class and colon colon new. And you have a method reference to the constructor. Okay, which means, like I mentioned, what is a method reference? Method reference is just a one way of writing a lambda expression which just had a method call inside its body. So what is a method reference for the constructor type? Method reference for the constructor type is just the conversion of the lambda expression whose body just had a call to constructor. So we would be writing a lambda expression like something like new hash set and parenthesis, and that lambda expression got converted to method reference and hash set colon colon new. Okay, Now let's quickly see all these examples which we just discussed. Okay, so this static method scenario we already saw that we have a static method. We want to convert this lambda expression into a method reference. As we discussed, mention the name of the class, mention the name of the method, and you have your method reference here. Now you are going to invoke it as you used to. str1.apply 1, 2,
We
3.
don't have to pass
Okay.
the string. It
No,
automatically.
string. Yeah, at the time of the implementation, we do not pass. At the time of the invocation, obviously we have to pass. That's how it is going to be invoked, right?
Okay.
Okay. But at the time of the implementation, no, you do not need to pass. That is obvious, and the compiler would take care of it,
So which is
right?
better? The code in line number 23 or 26?
I guess 26 is better because you have to write the less code, right? Why waste your time writing unnecessary thing which is obviously there, right?
Okay.
I mean, the same is with the lambda expression also, right? You can, instead of writing this lambda expression, you can write the anonymous class or they write the whole class yourself also, right? I mean, technically it is possible, right? No one is stopping us, right? But
Okay.
still we prefer the lambda expression, right? Because first is we write less code. Second is there is a performance benefit, right?
Okay.
I mean, with the method reference and the lambda expression, there is a no performance benefit if you choose one among the other, okay? The
Okay.
performance benefit of the lambda expression and method reference is same, but you write more cleaner code. You spend less time in writing the code.
Okay.
Oh, okay. So next is we want to see example of invoking a method on a particular object. Okay. So let's say we have these objects, user objects, Sarah, James, May, John, like all these. We put those objects into the list, and what I'm doing here is, yeah, and then we want to print this list. Okay, so I can write this lambda expression, right? That users dot for each, and in that lambda expression I pass this in the method I pass this lambda expression system dot out dot println and u. Okay, and u is one, each element of the list passed one by one, right? Okay, so then this would print the each element of the list. But see, this is a lambda expression. If I want to convert this to method reference, so see, you may be observing in this lambda expression that there is only one method call only, right? No computation, no calculation, just the method call. And like we discussed, a method, just a method call could be converted to method reference, right? So what we say is, on this system.out object, I want to invoke the println method. Straight enough, right? On this out object, I want to invoke the println method. So what I'm saying is inside system class, there is an out object. On this out object, I want to invoke println method. So which means I'm invoking this println, I'm invoking a method on instance of a particular type. On what type? I'm saying it is out. Okay. So here we see an example of invoking a method of an instance type on a particular object. So println is the method. Out is a particular instance on which we want to invoke the method. So we mention the type of the mention the object on which we want to invoke. We mention the method which we want to invoke. Okay. Or else we would have written the lambda expression all the way like this.
Okay.
Okay. Now we want to invoke an instance method but on arbitrary object. We do not mention on what object we want to invoke that method. That object is going to be decided at runtime. Okay, so see, see this, and there is this comparator interface which has this abstract method. Okay, there is this comparator interface, and where is the abstract method? Okay, it was at the top only. Okay, so we have this abstract method inside the comparator interface. Compare is the name of the method. It takes two arguments, O1 and O2. Okay, and it has a return type of int. So you must be already familiar that we use this comparator interface when we want to sort a list or sort any type of collection. Okay, so the sorting logic we mentioned inside this compare method, and then we pass this logic to the list or collection, and accordingly the collection or the list would sort itself, right? So the logic of the comparison of two elements we mention in this compare, right? And if we can compare two objects, then eventually cumulatively we can sort the a list or the collection itself, right? Okay, so just to summarize or to recall how this works is we take two objects of same type O1, O2, okay, and then when if two objects are equal, we return 0. Okay, so 0 is an indication that both objects were equal. Okay, if O1 is smaller and O2 is bigger, then we return negative -1. And if O, O1 is bigger and O2 is smaller, then we return +1. So the positive value indicates that O1 is bigger, negative value indicates that O1 is smaller, 0 indicates that both objects are equal. Like this, the implementation has to be if someone wants to provide the implementation for comparing two objects of a type. Okay. Okay. Now we want to provide the same implementation for our comparator here. Okay. So we have a list of string and we want to compare them lexicographically. By lexicographical comparison, we mean that a string uh, with the first letter as O and another string with the first letter as T. So which would be considered as a smaller string. So whatever comes in the alphabet first, O or T. So T comes T. O, no, so O comes first, right? So O is considered as a smaller string and T is considered as a bigger string. That's how the lexicographical comparison works, right? So we are doing in the comparator, we are writing the logic like this: s1 dot compare s2. Given any two string s1 and s2, s1 dot compare s2, and it would return an integer. Okay. So instead of doing the comparison operation or logic ourselves, we use the compare to method in the string class. Okay, which has already the logic implemented. Now again, why we are doing it? We want to demonstrate the method references. So this lambda expression only have the a call to another method. So it is eligible for conversion to method reference, right? So, but you observe one thing here. The S1 object on which this compare to method is invoked is this object is one of the object from the type parameters only, right? That this object is passed to this method as one of the type argument. And on the S1, we are doing the compare to method invoke and S2 is passed into it, right? Instead, here what we are doing is we are calling this println method on out object, right? And this out was not passed as a type argument into the consumer, right? So this S1 is there. Okay. Now, when we say mention the name of the class and name of the method string : compare to. So the confusion which happens here is, okay, this compare to method would be invoked. It is an instance method. It is not a static method. On which object this compare to method is going to be invoked. So each time to the comparators compare to method at any instance, two objects of string are going to be passed. Let's say 1 and 2, 2 and 3, 3 and 4, right? And whatever is the first object which was passed, on that the compare to method would be invoked. And whatever the second method which object would be passed, that would be argument to the compare to. Okay, so that's why we say invocation of an instance method on an arbitrary object, and that object is decided at runtime. You got it?
Okay.
Or you have some question? Okay. Okay. Good. Okay. So then at last we have this conversion of the invocation of the constructor from Lambda expression to the method reference. Okay. So to demonstrate that, I created this transfer elements method, okay, which takes a collection, okay, and then it takes a collection factory, and then it converts this collection into this collection factories instance. What I mean to say is, let's say I have a list and I want to convert that list into a set, okay, or let's say I have an array list and I want to convert that array list into a linked list, okay. So that is my requirement here, and this transfer element method does it for me. So the first argument or the first parameter for this method is the collection which I want to convert, right? Let's say I want to convert array list to linked list. So this should be the array list, and this collection factory, it should give me a new and empty instance of the destination collection which I want to have. So array list or linked list. So this should give me an empty linked list, okay? Or if I want to convert it to set, it should give me an empty set, okay? Okay. So what I do is I have a users list here, which I already created, right? This is a list of users, okay? And I want to convert this list of users into a set of users, right? So how do I do it? I pass my list of users and then I pass the collection factory. By collection factory, what it means is I provide the implementation of a supplier. And if you recall what a supplier is a source of data, right? So supplier is a source of empty objects of hash set. Okay. So each time I call supplier.get, it would give me a new object of new hash set, right? Okay. Okay. So I write a Lambda expression, and in that Lambda expression, what I'm doing is I'm just calling a constructor of hash set, new hash set. So what I would do here is collection factory.get, which is a supplier, and I would get a new hash set. And in that result, I would add all these elements from this source collection and then return the hash set, right? So basically, I iterate over all the elements and add it to the object which I created here. And this object I get from this supplier, right? And that's supplier I implement like this in the Lambda expression, that in the Lambda expression, I call a constructor new hash set. Okay. Now, because it's just a call to constructor, no other complex logic, only a single statement. That means it is eligible for method reference, more refined code. And how I write it is mention the name of the class and just mention new. That means I want to call the constructor of this class, and that's it. Okay.
Okay.
So to summarize, we have 4 types of method references: call to static method, call to instance method of particular object, calls to instance method of arbitrary object, and call to a constructor. And that should be it. Okay. Demo we already covered. For now, any questions if you have? And this PPT and these code snippets I would be sharing, so you can go over again to see what we discussed and go over few of the topics which we skipped for the time constraint. And yeah, that should be it. Any questions?
No, Kuldeep.
Okay, then yeah, I'd like to end the session. Okay, goodbye. Nandini, you have anything for me?
Yeah, no, nothing. Thanks.
Yeah, thank you, Nandini.
Yeah, bye.